Hello, everyone. We're going to look at measures of spread today, which is another way to show how data is distributed. So you've seen distributions of data recently with the histograms. We have like normal distributions and skewed distributions and so on. And if you look at the data again from the previous lesson, we had these marked distributions, and obviously the bulk of the data is kind of in this range. And then there were a couple actually. I think there was an extra mark that I had added in my lesson. It was a little higher than that one even. And so basically those numbers don't really seem to fit the pattern, and so we can analyze them. The spread of this data better, and we'll actually be able to decide whether those numbers should be included or not. Okay? So the new kind of way to show distributions and spread of data is called a box plot, or sometimes called a box and whisker plot. So they call these little lines that we extend out the whiskers. Um, so things to know about this right away. Maybe I'll wait for when I do there's a video that you can watch on your own. I'm just going to do it myself so I don't have any copyright issues on my YouTube channel. I guess I'll start here. So basically the main thing to know, this is for 3 different distributions of data. And in each one of them, this bottom whisker section is 25% of the data. This section is 25% of the data. This section is 25% of the data, and so on. They're each 25% of the data. So they are called quartiles as a result, right? So it's just 1/4 of the data. So each one is called they're called quartiles as a result. So what you have is this is the upper end of the first quartile. So it's listed as Q1. This is the upper end of the second. So Q2, upper end of the third, Q3, and finally Q4. Okay. They will also, and you'll see this again when I do the official lesson for it or whatever, but this range here, the middle range, is called your interquartile range, and it's the middle 50%. Okay, so it's the middle half of the data. So you'll hear the term interquartile range, or read it in questions. So interquartile range, or IQR for short, it's often listed as. Okay. So that's the idea. And so, the idea of this is that at a glance, you can easily see how condensed the data is. The bottom data set is obviously a lot more focused, between 4,000 and, almost 5,800 or something. Whereas the company B has, numbers that are all over the map, a lot more variation in the data. The spread is a lot more. So if you're looking for like consistency, depending on what these companies are measuring here, the bottom one is more consistent, right? With a couple numbers that are out from the range, but consistency, if it's a factor, could be showing that the bottom company might be the better one. So the benefits of box and whisker plots, obviously they take up a ton less space than having a bunch of histograms. So picture this is versus histogram, right? So if you have a histogram that's like this and you have all your bars and so on, whatever, picture a histogram like that, and picture that in comparison to just a nice little box plot that would show the data, going out to each range and so on. You picture that being a lot nicer, right? Not supposed to have arrows, really, it's just lines, but you get the idea, right? That could be a representation of that histogram. So they're a lot smaller. They give you a lot of good information as a whole, right? So the histograms, you notice things like this little fluctuation and so on. You're looking at like individual data points, whereas the box plot kind of erases that individual fluctuation and gives you a picture of the data as a whole, which is nice. That way you're not distracted by individual fluctuations. They're good at showing outliers, and so on a histogram, if you had a bar like result way out there, you're not sure whether or not to count that one or not, right? And so in this case, this bar might go all the way up to there, and we'll see soon in a future lesson um, whether or not we should include that number or not. Okay, so this is possibly an outlier out here. And there's going to be like a mathematical process to decide whether it's an outlier, whether it should be included in the study or not. And you can compare data a lot quicker, obviously, right? In this first one here, you can easily compare those really nicely in comparison to the having a ton of detail thrown at you with histograms. So what do I want to say there? That's nothing really. Yeah, no, that's fine. You can watch that video if you want. I'm going to show my version of that video here. Okay. So when you're doing a box and whisker plot, you're going to have these 5 key numbers. Okay. So you're going to have your minimum number. You're going to have your upper quartile, like the upper end of your lower quartile, so the 25%. So Q1. And again, this is 25%. You have your Q1. You're going to have your Q2, which is the median. So this is Q2, but it's the median of the data set. So we should maybe do that next here. So you're going to have the median of the data set. So when we look at the median of the data set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So 5 on each side. And so the median would be the average of those 2. The average of 8, 10, of course, just be 9. So that's why we have the median, or that middle of the data, the Q2, at 9. And then we have we'll talk about what Q1 and Q2 are, or Q3 are shortly here as well. Q3 and then Q4. Okay, so let's get at that. This one's your maximum, or Q4. So Q1 and Q2 are the middles of the upper and lower half. So if you're looking at the data on this end, then the middles of those ones, right? So we're looking at that, the middle of the 8, 8, 7, 3, 1, whatever, it'd be a 7. And the middle of the 10, 11, 12, and so on would be the 12. Okay, so that number there, the 7 and the 12, they are the median. This is like the median or the middle of the lower half, or lower half. So it splits it into 25% and 25%. And then, of course, this one is the median or the middle of the upper half. Okay, so that's your Q1 and your Q3. Okay, and then the other thing I mentioned was the important idea of this center section where you have like half of your data. This middle section is kind of important, where you have this is your interquartile range, right? It's your half of your data. So the numbers that were calculated, or that they're just seen from this and so on, we have the 3 and the 18. We had the median in the middle was the 10, and then we had the 7 as the middle of the bottom half, and the 12 as the middle of the upper half. So one thing I didn't mention at the start was, notice that these are in order, right? These need to be in order for this to be easy to do. So need to be put in order, just like when we did medians in the review lesson about that. Okay, that's your Coles Notes version of what box and whisker plots are, how to make them. So if we're looking at just step by step, we're going to collect and organize data and look at the data basically. So organize them from smallest to biggest. Calculate the median, so the overall middle of the entire set. So median of the whole set. And then calculate each of the quartiles. I need to change this lesson to be a little more detailed here. That means the median of the lower half equals your Q1, and median of the upper half equals Q3. This was, of course, Q2 here, the median, right? Let's separate that out a little bit. And then basically create and plot a line for each of your quartiles. You're actually going to, on your number set here, you have a number line, first of all. It goes along with this. And so you're going to put your Q2 in place. You're going to put your Q1, whatever it happens to be, in your Q1 and Q3 in. And then, so this was like basically, it doesn't really matter which order you're, but first, second, third, maybe whoever, like something like that. Because typically you're going to get that, you got to get that median first, and then the lower half leads to the next one and the next one, right? So first, second, third, kind of going on like that. Fourth would be to put a box around this and say, okay, there's my interquartile range. So fourth step, box in the interquartile range, that middle 50%. And then after that, you're going to put whiskers out to your maximum. But we are going to also look at whether or not there's an outlier. So the first version of whisker plots is just to go to the max and the min, all the way out to the max and the min, whatever they are. Okay, but we are going to be looking as well as to whether or not there are outliers and if we should get rid of them. Okay. So create the box that connects the quartiles. That's your interquartile range stuff. It's not detailed enough, but it's set up for me to use as a template. So interquartile range, that's going to be part of the process later on. So this is about outliers. So let's focus on that once we've established and practiced the main process a couple times. Okay, we'll come back to that one. All right, so collect and organize the data. So you see this data set, 28, 18, 30, and so on, right? All you would do is just pick out the smallest one from the set. So it looks like a 9, right? So grab the 9 and let's see, group for me. That one, group. There we go. So you'd have the 9, stroke it off the list, and then the 18, cross it off the list, and so on, all the way along. So you just order them off one by one. Okay. Crossing off as you go. It's a handy way to go about it. So there's the ordered data set. And then from that, you're then going to, I don't know if I really want to follow this page. It's a lot of words that we've already talked about, but we're going to calculate the median, right? So that ordered number set, this page is fine. That ordered number set, we're just going to split it into 2 halves, and notice that since we have an even number here, we're going to do the average of that middle set, and that's what we're going to call Q2. And that's the first thing we'll put on that number line. Okay, so average, of course, is always the 2 numbers added up and divided by 2. So that's going to give us 40, 50. Let's just do this in full so we don't lose anybody. So the 24 plus the 28, carry the 1, you get 52, divide by 2. 52 divided by 2 is 26. Right? So we can put that Q2 value on the number set as a 26. So right around here. Okay, that's my Q2, which is the median of the entire set. Okay. This file, if I remember right, doesn't have some of this stuff on the next pages, but I'll come back and grab it. But up here, I guess we did this stuff, right? We said, okay, we looked at that and said, okay, the 2 middle numbers are the 24 and the 28, and so we added them together and divided by 2. Got our 26 as our median or the Q2. Okay, so there's some definitions in here that seem intimidating, but this whole idea of it being Q2 and whatnot. Obviously, you're going to have the 5 things in order. You're going to have the middle. You're going to have the middle of the bottom. Sorry, the minimum. You're going to have the middle of the bottom half. You're going to have the middle of the entire set. The middle of the upper half, and the maximum. That order is not in question, and so that at that point you can just, once you have them all on there, if it help afterwards, you could label this as Q1, Q2, Q3, and Q4. Okay, so that should help those straight if you're having trouble. So now we're gonna get the Q3, right? So we're gonna get the sort of the upper quartile, they call it. And so I want to go back and grab. This is where I was saying I could grab it. I'm just gonna grab this stuff and put it on here so we can use it to think about it. And there we go. So in that bottom half, right, we'd be looking at the 9 to the 24. The middle of that is going to be the 19, right? So just look at that for that bottom half here, the Q1 part. We have the middle of this, we'd have basically the 2 on each side, and we have the 19 as our middle, right? So we're going to have in here the 19 is in the middle of those. And in the top half, we're going to have even numbers on each side, so we have a 32. Okay, so we're going to have a 19 and a 32. It's our upper quartile. Okay, so again, if it was even numbers, you'd be doing averages, and odds, you just pick the middle one, right? So in this case, we had an odd number in the lower half, so it's literally just a middle. So we should be good to go. And so at this point here, we can transfer that information back on there. We had the 26 from the Q2, the median of the whole set. So on this page, it looks like that. And then we have our 19 and our 32. So a 19 and a 32. There and there. Okay. So in terms of, and we might as well throw on our minimum as well. It's pretty easy to see the minimum was 9. We're wondering if we're going to keep it eventually. But for now, we're just keeping it. And then I'll get to 57. Right? Again, wondering if we can keep it. Okay. This is the one that gets boxed in as your interquartile range, and then the whiskers just extend out to the max and min. Okay. So this is where it's pretty obvious where you have like the first one, the second one, the third one, and the fourth one. But you don't even necessarily have to label those on there. You just kind of need to know what they are and so on, right? So knowing that this is the middle 50%, right? Knowing that this is the bottom 25%, and so on and so on, all that stuff. You just need to know what all this is representing. Right? That pretty much sums that up. The tails, get put on there as they need to be, and so on the other page. So just drag those in place so this page doesn't look blank, but that's done. Okay. So if we're doing another one of these, I'll just run through an example from the website. Let's go with one of these guys. Tab. And so that's the number set it came up with. Let's do that. So basically, let's just show like the idea where you would put them in order. So the 8 would be first, and then the 6, and then the 8, and so on. Right. So I can just, because it's digital here, I can just click it. You can see here, we'll just run through the ideas of this. We got the 3 and 3 on each side. So the 17 is our middle number. And so we can move the middle of all of it to there. The lowest is obviously the 6. So we can move that out, this up. The ends are established. And then we just have to think about the middle of the bottom half, which would be the 8 and the 14 average there. There's 2 different ways of doing this. I'm going to do a quick check here. I think maybe they might look at this bottom 3 and say the middle is 8. Then the top 3, the middle is 25. Now the other way that some people do this is they include the 17, and so they do the average of the 8 and the 14. So the 8 and the 14 divided by 2 gives you 11. So they might want it at 11. Let's just check and see what it says. So they're happy with what I did. Okay, they're happy with the bottom half excluding the 17. It's kind of a personal preference almost. A lot of people do it one way or the other. So just to recap, what here we did, okay, excluding the 17, we have the 6, the 8, and the 14. So the middle, that's 8. The top 3, we have the middle's 25. Done. Some people might have done the average of the 8 and the 14, so move this to 11. And then here, the average of the 21 and the 25. So that would be 21 plus 25, right? 21 plus 25, and then divided by 2 would give us 23. So this one could have been quoted as 23. Okay? It's probably going to say no because it's interpreting it the other way. That's so put these back to the 8, the 25. They were quoting it as. Okay, we got it. Right? So the answer is what we said. There really is two ways of thinking of that one, though. So good to kind of hear about both. So each one of these is just done that same way, right? So this one will get modified. We've done one of those. I'll put that one on the page we just did together so we have a record of it. Or just undo that. No, that's the one. Never mind. We're good. So for the first kick at the can kind of thing, you just need to just practice a bunch of those for sure. And I'm gonna separate it out to well, I guess because it's a video, I could just keep going. With my in-school class, we separated it out. Maybe I'll just keep going. You'll have this full data, so this full page, right? And some of these say, ask if there are outliers. Okay? So maybe press pause right now and come back to it to finish it. But I don't want to have the full page out and you not knowing how to do that. So I'll just keep going. So the full version is to get rid of outliers. So what you have to do is you have to calculate the actual value of the interquartile range, which is the like in this case, the 25 take away the 8, right? So the 25 take away the 8, have a spread of 17 there, right? Going from highest to lowest, a spread of 17. So they consider numbers that are on the outer edges to be outliers if they're more than 1.5 of this interquartile range above or below the outer quarters. So from here, extend 1.5 of those. So clearly, in this case, there isn't going to be an outlier because we have a huge interquartile range. You're going to add on 1.5 of those so that the outer limit would be way over here where my mouse is pointing, whereas our minimum is only there. Okay, so that's the idea of it. So that's what they mean by Q1 take away 1.5 quartile ranges, and they call that like a lower limit. Then the upper go extend from the top. Again, extend 1.5 of these, so it's going to be way off to the right, way off the screen. The maximum is way within that, so none of those are going to be outliers. Okay, but that's what you do to figure out those outliers. If there are any outliers, you actually just put them as dots, and you only extend the whisker to the upper limit, or actually to where the highest number is before the upper limit. Okay, so to get the point across here, look at this sort of representation of a data set. And if you ask someone how many outliers there are, really not an easy way to decide at this point, unless you do the calculations I'm talking about with the 1.5. So this could be certainly considered an outlier, probably, because it's way off of the grouping. But maybe this one is 2, maybe this one is 2, maybe this one is 2, right? It's kind of up in the air, and it shouldn't just be up to someone to decide. We want to have right here an abstract mathematical process that's going to tell us whether or not something is an outlier, rather than relying on human judgment or emotions or whatever. My grade 9 class last semester had a very tall student. Named Lucas, and so we did all of the heights in the class. And Lucas's result, everybody would guess that it's an outlier. And when we analyzed the numbers, it actually wasn't an outlier. He's a lot taller than everybody else, but not enough to be considered an outlier. Okay, so his data would be included in a study, let's say, rather than excluded because it's so far off from the regular values. So the actual data from this graph is this. Okay, so then we're looking at the median of that. So for the median of that, we need to figure out how many there are. So there's 19 of them. So if you did like half of that, you'd get 9.5. And so you round down and have like 9 on each side, right? And it's an odd number set. And so we're going to have we're going to have a single number in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So the middle number is the 23. And then we're going to keep going, and of course do the middle of those, right? So the middle of that stuff, we have the 9. So there's going to be 1, 2, 3, 4, 1, 2, 3, 4. We have a 19. The middle of this half. And this is another one of those ones where should you include the 23 or shouldn't you? It's a judgment call. I'm just showing this way as my choice for this. But sometimes people might do it differently. So 1, 2, 3, 4, 1, 2, 3, 4, get a middle. But otherwise, you'd be including the 23 and averaging the 19 and the 21 and the 24 and the 24. Just changes, your overall slightly. So we have all of our numbers actually already identified. We have our minimum. We have our first quartile, the upper end of the first 25%. We have our second quartile, the middle of the whole data. We have our third quartile, the upper end of the third 25%, and the total top end Q4. Right? The top end of the fourth 25%. In other words, all of the data. Okay, so we'll remember those numbers, the 5, 19, 23, 24, 25, and we'll graph it, right? So this is all of that stuff, all just what I just did on the other page, right? So I'll skip that and go ahead to, again, this is the same stuff again, right? That middle number, so it's just pages showing the idea of all that stuff. So I just went ahead and did it because to do that. I'll just show those so they're not just blank pages or whatever. Moving on to the final result here. So let's move this down and show the actual numbers. So our numbers needed to go from 5 up to 25. And, for the purpose of what we're doing here, I don't have to be super accurate with measuring this. I could just start at 5 and then just do 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I made it. It was close, right? But we have 5 to 25. But, use a ruler normally and get nice even spaces. But just to keep this video rolling along, I'm just going to get the idea across. So we have our graph going from 5. We said we're going to use these numbers again, right? 5, 19, 23, 24. So 5, 19. So backtrack from here. We need to go up to 24 was the upper one. Then we had 23. So 23. Then we had the 24, the 23, and the 19, right? So down to 23, 22, 21, 20, 19. So basically, there's your numbers. And if I had labeled them all, it would have been easier, but you got the idea, right? So we box this in. Oh, wait now. What's our other number? Boxing in now the 19. So the 19 to the 24. The 25 was our upper limit. I just had to double check there. So we're boxing in the 19 to the 24. 25 is our upper, and 5 is our lower. Okay, so there's a rough box mystery plot of that thing. But we are wondering, like, should we really include that one? Should we really include this one? And so we look and we see what we have, right? So in order to do that, we need to get the interquartile range. So in this case, the interquartile range is 24, take away the 19, which is 5. Okay, in other words, it's right here, interquartile range 5. Okay, so if we extend this interquartile range by 1.5, like the 1.5 of that interquartile range, so let's do 1.5 of those. So do another half of it, let's say, approximately at least. You can visualize here that, yeah, we're going to have some outliers, right? That the actual lower limit is going to be somewhere around there, and that's on the next page, but I've already sort of telling you about the idea of it. Okay, extending this far on the top end, you can tell we're not going to have an outlier up here. It's going to be well beyond the maximum value. Okay, so that's where we do this number here officially. So we have the 1.5 times interquartile range is 11.5. So we're or sorry, uniquartile range is 11 is 5, sorry. And so we're multiplying by 1.5 and getting the 11 and a half, right? Saying that wrong. Oh, I see now. Never mind. Yeah. So we have the uniquartile range is the 5, 1.5 is a 7.5. We're taking away at 7.5, getting our new lower limit. Okay. Our new lower limit is equal to 11.5. So if I go back to this page and officially declare where the lower limit is, it's going to be at 11.5. Well, if you look, 6, 7, 8, 9, 10, 11, 11.5, where I had ballparked with my arrows. Okay, so that's your new lower limit. So you adjust the box plot to be like that. And then this is pretty much done because there isn't an upper one, but you would then show the other data points. So instead of having this all drawn in, you get rid of this. And you just show the dots to show that they exist, but justifying that you've excluded them. So the 5, the 7, and the 10, maybe. So here, 5, 6, 7, 8, 9, 10. And so there's your outliers. So now we have a mathematical justification for saying there's actually 3 outliers based on the consistent judgment amongst all people that you look 1.5 interquartile ranges beyond on each end. Okay, so that's the sort of the more official version of deciding whether there's outliers or not. Okay, and so obviously, what we ended up with was there was these 3 outliers, right, from what we had said. So that's the correct answer on a multiple choice question, let's say. Okay, the upper limit one, you'll see that we're going quite a bit beyond, right, all the way up to 31.5, right? So on the upper end, there really wasn't any outliers at all. So there was no high outliers. Okay. So yeah, there's the 2 versions of the box plot. Here's the nice, digitally produced version of the box Whisker plot, and then here's the one that's showing the showing outliers, which is obviously a bit better. It's more detailed and giving you better, more information about what numbers you should trust and include and make judgments based on. So this number set here, if you look at it, let's go through the digital version of this one. I think I have it ready to go. 17, 17, right here, I believe. Right, so if we order those values, then we look at the middle. So I think we're talking about 1, 2, 3, 4, 5, 6, 7, 10 of them. So on my picture here, we got 10 of them. So we're gonna have 5 and 5 on each side, right? So 1, 2, 3, 4, 5. So we have 5 and 5, like that. And so, yeah, 1, 2, 3, 4, 5. Sorry, better do that again. 5 and 5, and so we need average of this, right? So we're going to have now. Ooh, this isn't the picture that's in order. Good thing I noticed that, right? So we need a picture of the one that's in order just to speed things up here. And here we go. So put it in order first, kind of an important step. So now they're in order. Now 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Right? The middle of these is 17 and 17. So obviously the average, therefore the median is 17. Okay, so we're going to drag the median over to 17 on the file program here. So drag this over to 17. I'll get that out of the way. So there's the median of the whole set. Then we'll go to here to make it easy to show what we're doing. We have that 17, the average of those, and then we're going to look at the bottom half and the lower half here. So we're going to have a 13, right? 1, 2, 3, 4, 5. Yeah. So the bottom half, we're going to have a 13, and we're going to have an 18. 2 on each side, right? There. So we're going to drag that to 13 and 18. 13 and 18. And then our max and our min all the way down to 1 and up to 27. So let's check the answer. It says, yep, we did the right stuff. Okay. So, and now the extra thing is to say, okay, well, what do we think as far as outliers go? Okay. So I would say that's good start. That's an older one. Let's capture that. But we're going to look and see, like, are there any outliers? Okay. I'm not sure if I'm spelling outliers are right and wrong, if it's supposed to be 2 words, but just a mathematical word, who cares? So are there any outliers? So in other words, should we be including each of these points on the very ends, right? That's where we can decide. Okay, so what we're going to do is we're going to look at that interquartile range, right? So the interquartile range is 18 take away 13. So it's just 5, right? And so then we're going to be looking at saying, okay, well, our lower limit. So let's do the math down here. Our lower limit is going to be 1.5 times the 5. So the 1.5 times the 5 is going to be 7.5, but just to see, you're going to get your 7.5, right? So we're going to add a 7.5, we're going to extend the 7.5 both ways. So I should actually have in here lower limit is going to be the 13 take away 1.5 times the 5. So 13 take away the 7.5, and 13 take away the 7.5 is 5.5. So we're actually going to have this only go out to 5.5 right there. That means we're going to get rid of, I'll use my white marker here. We're going to get rid of all this. So I'm just sort of using a marker to sort of erase it sort of a little bit. So we can show, like, yeah, we got rid of that, but I'm leaving a little bit of a record of it having existed. And then we can show the 1. It's just the 1, actually, right? Because the 6 ends up in there. So this one's an outlier on this end. Okay, so there's 1 outlier on the lower end. And then if we add on to get the upper limit, let's see if there's an upper limit here issue. So 18 plus the 1.5 of 5. Obviously, we could have just did the 18, 13, plus 7.5. So the 18 plus the 7.5, and we get 25.5. Right? So we get 25.5. So there is actually an outlier on the upper end too. So we're going to go to 25.5. So that's there. So there's our lower limit and our upper limit. And so we would have it go to there. Then we're going to get rid of this whisker that went all the way out there. Right? Get rid of the whisker on each end. And then we just have to look and see, like, okay, well, what numbers are there beyond 25.5? And it's literally just the 1. There can be more, like you saw in the other example. Okay, so if the person who designed this GeoGebra version of things, wanted to include outliers, this would be the number that or the result they'd program in to have as the right answer. Okay. This is one that I did in my in-person class today that came up when I was resetting the program to come up with one that likely had outliers. And so we judged in class based on this interquartile range being very small. Pretty obvious you're going to have some outliers, right? So did the calculations. It had a bit of a weird thing where the Q2 and the Q3 were both 13. So this right here is Q2 and Q3. That's fine. It's just the way it is, right? One's never going to be past the other one, but they can be on the same spot as you see here. Yeah, and so we calculated the lower limit and found there was just still 1 outlier on each end. So it's just another example worked out for you. But so, like I said, I consider this to be about 2 days worth of work, maybe even 3. So you'll just have to watch for when another lesson gets released for you to work on, right? And of course, post questions and so on. But I'd kind of encourage you to work on just the main definitions and making the block sums for plots as your first stab at it, and maybe watch the rest of the video, or easy to say now, I guess, because you've already gotten to this point if you're listening. But if you divide it up into 2 pieces, at least it'll make it a little bit easier to get the hang of. So if that helps, let me know if you have any questions. See you later. Thanks for watching.